Hi there, folks, and welcome to the latest episode of Down to Earth. My name is Eric Edelman, and I'm your host. But, some of you that might have seen a lot of Slooh shows here in the past might know that I have a little bit of a specialty that I tend to enjoy or say be a little bit obsessed about when it comes to astronomy. And that is actually exoplanets, planets that are around stars other than our sun, planets like those in our own solar system are maybe a little bit different, but outside, extrasolar planets. I love talking about that stuff. I find it so fun, so just on the cusp of what we're learning about here, about our very own universe. And so when there's something that maybe is a little exoplanety that happens in the news, I love to talk about that topic. And what do you know? This week, such a thing as so just happened. And on July 7th, there was an announcement that there was a planet that was maybe even more Tatooine than Tatooine is. And we're actually going to go through that, figure out exactly what that might mean. But first off, to start off with, let's get a little bit of a grip on what exoplanets we know about there. What's around our place in the galaxy. And so to do that, we have a little bit of help here tonight from a special NASA JPL program. It's actually called Eyes on Exoplanets. And so what that does is it shows us what the different exoplanets are around our galaxy. And so we're seeing that right here being piloted by the wonderful Trisha Ennis, our show producer in the studio. And so she's showing us, this is the live view of the Eyes on Exoplanets program. And so the brilliant yellow dots that you see speckled around the screen, those are different exoplanets. And as she hovers over them with her mouse, you see the names of different types of exoplanets. And so really in the center of that ball, that's where we are. That's where the sun is, where we reside, because the more planets we can see are the ones that are closest to us. So we're going to be surrounded by a ball of the known exoplanets. But then, on the other hand, there's this interesting little feature that we also see where there's a little bit of a tail coming out of the right side of the screen, where there's a bunch of exoplanets that we see right there. And those all have the same sort of name. They're all Kepler exoplanets, because those are all planets that have been discovered by Kepler. Because what the Kepler spacecraft did is it looked at a very particular point in the sky for the course of years. And so during that time, it was able to discover a lot of different exoplanets. And some of those exoplanets were very interesting, very strange, and in some ways captured the imagination of the public. Like one, for example, is Kepler 16. That system is very interesting. And what we can actually do with this program is we can go to different stellar systems. And so what Trisha's doing here is she's navigating us over to the Kepler 16 system. We just type it in, and voila, we're traveling through space, going to a whole other star system other than our own. And so here we see the Kepler 16 system. And what's so interesting about this is we see that there's this planet, Kepler 16b, that's orbiting these center stars, plural, because this is a binary star system. There are two stars sort of orbiting each other in this a cosmic waltz, and then around them is the planet. And so the cool thing about Tatooine was that you would see two stars rising in the distance with this planet. And so the same with this planet, Kepler 16b, we have that same phenomenon where there are two stars that this planet is orbiting. And so let's get a grip actually on what this Tatooine is like. There's different ways we can do this. We can actually compare this planet's orbit to the orbits that we have in our very own solar system. That's an option that we can do. And so that's what we're seeing actually right here. So the orbits of our planets and our star are sort of superimposed over this Kepler 16b system. And what we see is that Kepler 16b is sort of orbiting these two stars at a distance right about of Venus's orbit. And so that's the second planet closest to the sun in our solar system. So, and it's a bit of a hot planet. But things are a little bit different in terms of Kepler 16b's situation. For example, if we take a look at where Kepler 16b's habitable zone is, that might tell us a different story than we might first assume. So the habitable zone being the places where liquid water can form. Our Earth is in the habitable zone for our star, our sun. And that's why we're able to be around, because we have that drinking water. We have those nice mild temperatures on our planet, as opposed to the extremes that we find on other planets in the solar system. And so what NASA's done for different exoplanets out there in the galaxy is it's calculated where the habitable zone would be for those planets based on how hot the stars might be, how much they're radiating those planets. And so this greenish, grayish sort of circle or uh, annulus that's sort of surrounding the region right there. That's the habitable zone. If a planet is in that annulus's location, then that means that possibly liquid water could exist on that planet. And so they could possibly have what NASA or scientists might think as life in that region if it had the right building blocks for that. But to be honest, we're not going to find a lot of life on Kepler 16b because that is a Jupiter-like planet. It's a gassy giant, so we don't think it could host life as we know it ourselves, but it is in that interesting habitable zone region. And so what that planet does is it poses a potential there for us. If there's a gas giant planet that could orbit the habitable zone of two stars, a binary star system, then maybe one day we might be able to find a terrestrial planet that does the same thing, an Earth-like rocky planet that maybe in more ways than we could see with this one could potentially host life, could host a Star Wars-like universe. Who knows? But this is sort of just a little bit of a primer, a little bit of an initial step into what we have in terms of exoplanets here in our galaxy. So there's a few we found. We found a few thousand, and a lot of them are due to Kepler. And so now what we're going to do, though, is we're going to switch gears a little bit so we know what planets we have out there. But now we're going to figure out how exactly we discover them, figuring out what those types of discovery methods are. Because there's actually a really cool graph that we have that actually shows you year by year. Oh, here it is popping up. The number of exoplanets discovered and which methods that we used to discover them. And there's a few different methods out there that are really popular. And so you'll actually see that there's a lot of green all of a sudden in the last few years. The green started to come and then it just zoomed up into popularity. So that green is actually showing us the transit method, which is used by Kepler. The Kepler used this green transit method to discover planets. And so all of a sudden, when Kepler came online and was using this transit method, a lot of planets started to be discovered that way. We're actually not going to be talking so much about the transit method here today, but just in short, transit method is all about looking at the light from a star, seeing if that light dims in our view, and possibly that dimming could be because a planet is blocking some of that light. So that's how the Kepler program looks at different planets out there. There's a couple different methods. There's the transit method, there's the radial velocity method, that's the blue one that you see there. But the one that we're going to be talking about here today is actually the one it's a little bit of a small color, but you should see red on some of the tops of some of those bars. And that red actually stands for direct imaging. So directly imaging that planet in order to discover it. So like you take a picture of your friend in front of Niagara Falls, we take a picture of that planet next to the star. So directly seeing that planet through an image. That's how it's discovered. It's a very difficult method to use because the star in the center of that stellar system is going to be very bright. And compared with that, any light from a planet will be very dim. And so it's a struggle to block out that light from the center star to be able to see the dimmer light coming from that exoplanet that orbits it. So oftentimes with this method, you find exoplanets that are very distant from that center star, have really far away orbits, so that they're maybe a little bit further away from that bright light of that star, and also very young, hot planets that are emitting a lot of heat, so they're a little bit brighter when we look at them in our telescopes. So there's a lot of different instruments out there that do try to directly image planets. And one of them is actually the Very Large Telescope, the VLT. That's its actual name. It is what it says. It's a very large telescope. And that telescope is actually in the Atacama Desert in Chile. And so we see it right here. And so this actually shows you, while it is one telescope, it's actually four 8.2 meter telescopes that are individual telescopes that can be used for individual science themselves, but at the same time, with their powers combined, not Captain Planet, but can become a very great telescope. They can do things that they could not do on their own. And so we're actually not going to be focusing today on them combined. What we're looking at is the third unit out of these four different individual telescopes. And that third unit houses an instrument known as SPHERE, or the Spectropolarimetric High Contrast Exoplanet Research Instrument. So quite a mouthful, a lot of acronyms here in this show, but SPHERE I think is a great one. And it's actually, yes, it's that box that we see on the screen. So it's not a, it's not an actual sphere, but sphere is a box, if that makes any sense. And so what SPHERE does is it directly images exoplanets. That's one of the things that it does. And on July 7th, it came out in the news that it has imaged a very cool exoplanetary system. And actually tonight, live through the Slooh scopes, we're looking, we have an all-sky view in Chile, which is right near the Very Large Telescope. We have an all-sky view of what the Chile sky is sort of looking like. And we were actually going to be looking a little closer with the Slooh telescopes, but as you can see, there's sort of some clouds there that are blocking some of our view. But so what we were going to do is actually show sort of the star field. But what we can show you is the sky itself. This is the sky that the VLT was situated within, that it looked toward that system. And it saw a very intriguing system, 320 light years away. It's in the constellation of Cygnus, the Swan. And so what this system is called is HD 131399. Here it is popping up on our screen right here. And so this system, it has one exoplanet so far that we've been able to see and 3 stars. So not a binary system, but a trinary system. So 3.5 times Tatooine, a very interesting system. And so this is the SPHERE observation that we were able to get from that. And so just to understand this system, at the top left, the brightest dot that you see, that's the main star. That's the A star. There's A, B, and C are the 3 different stars. And then sort of near the bottom right, you're going to see sort of 2 dots that are sort of orbiting each other. Those are stars B and C. And so how this trinary system works is there's that one main star, the A star, and then the B and C stars are sort of orbiting each other and orbiting around the A star. And then how exactly does the planet fit into that? So then you might see a little bit of a dot in between that bright dot and the 2 smaller dots in the bottom right. That dot is HD 131399b, and that's or lowercase b, because the upper cases are the stars. But the lowercase b, that is the exoplanet that we have in this system. And what that exoplanet does is it orbits around that main star A. And then the stars B and C, they orbit around those 2 objects, the star and the exoplanet. So it's a little interesting. It's a system that we probably don't have a lot of familiarity with here on Earth. If you know a system like that, if you've experienced one like that, please let me know. That would be amazing. Send me pictures, please. But this is very, very alien to what we know in our own solar system, where we're just orbiting this one center star. And so here we're seeing an artist's conception right there, where there's that big star, there's that small planet orbiting around that star, and then there's those 2 stars in a tight orbit that are orbiting around that entire system. This is HD 131399. And so the fact that it has this really interesting triple star system that this exoplanet resides in makes its orbit really fascinating. So what happens is this planet is actually very distant from its host star. It's actually, it orbits about 80 AU distant from that main center star. And this, for comparison, Pluto tends to orbit about 30 to 39 AU. So this is usually about more than twice as far away as Pluto gets from our sun. It's orbiting this center star. And so it takes a very long time for it to complete one orbit, about 550 Earth years. Very, very long. And so during this time, if that planet is on the side of the star where it's facing all 3 of those stars in one direction, could we put up that main image taken by SPHERE real quick? I think that's better to illustrate this point. Yeah, thank you very much, Tricia. So if that small dot was on the other side of the star than it currently is, if that little small dot was at the top left of the screen, so that all the other stars were sort of in a row, sort of below it, then it would have a normal day like we would expect we have here on Earth, except they just see 3 suns rising every morning. Except, though, that's going to only be when it's on that one side of the star. When it's where it is, where we see it here right now, in between the three stars, with one star on one side, two stars on the other, then something very interesting happens. So, as you're going to see star A, the big star, it's going to rise. And then when it sets, stars B and C will rise. Then when B and C set, star A will rise. So this planet will be orbiting and will be in perpetual day because no matter what side it looks on, there's going to be a star. So actually, for 140 Earth years out of its 550-year orbit, it will be in pretty much perpetual day. So a really interesting system with a really weird calendar, however you'd work that out, because you would not experience nighttime for around 2 human generations, and then you'd have that day and night cycle. It'd be very crazy. And so one question maybe is, would this planet be habitable? And well, it currently is certainly not habitable because it is very, very hot. It is 577 degrees Celsius or 1070 degrees Fahrenheit. So very, very hot. And so maybe a question that might be in your mind, though, is why is it so hot? Because I mentioned earlier, it's twice as far away from this main star as Pluto is from our sun. And Pluto is very cold. It's not about the three stars heating it from different angles. That's not why it's so hot. It's so hot because it's so young. This planet is just about 16 million years old. It's a baby when it comes to planetary terms. Like, for example, our Earth is 4.5 billion years old, so a lot older. And so when the planets are really young, they still have a lot of that initial heat from the violence of their formation. And so that's one of the reasons why this planet is very hot. Eventually, that heat will dissipate and it will get a lot cooler. But even if it was a little cooler, still probably wouldn't be habitable because it's a Jupiter-like planet. It's about 4 times the size of Jupiter, a very big gassy giant. So it's not really going to be something that we in our minds might expect would be habitable. We haven't found a way to inhabit a gassy giant just yet. So some problems with living on this planet, but it also, I think, in ways like the Tatooine, like Kepler 16b did, can really inspire our imaginations in terms of what is possible. A really fascinating system. Here's another artist's interpretation, which shows that planet when those three stars would be rising and setting together. So it wouldn't be the perpetual day cycle. There'd be a day and night cycle. It's on the other side of things. And so already there's a lot of, even though this was just announced on July 7th, there's already a lot of art and inspiration that's come from this series, from this star system, because it's so interesting. And it'll be great to see sort of maybe the conversations that come out of this HD 1313999 system. I'd love to see somebody nickname it something fun because we have, the Tatooine-like planet for Kepler 16b. What could this system be? That might be my challenge to you folks here tonight. If you can think of a good name for a system like this, let us know. The chat box, if you're watching this live here on Slooh.com, will either be to the right of the show or beneath it, just scrolling down a little bit. We'd love to hear your opinion on all of this because there's a lot of stuff to chew into here. And also, on the other side of things, I think that this is really a very fun discovery because it coincides really nicely with the arrival of Juno at Jupiter, a Slooh show that just happened on July 4th. And so Juno at Jupiter is a gaseous planet that is in some ways very similar to this planet that we're just seeing here on our screen conceptualized by this artist. And so there's some, I think, relationship to be had here. As we look out at this young Jupiter-like planet, maybe we'll be able to learn a bit about what our Jupiter has gone through in the past or what it could have been as a young Jupiter-like planet. And as Juno learns more about Jupiter, maybe we'll learn more about the potential that this planet out here in the distant parts of our galaxy holds. What can this planet do? What is it capable of? And maybe what could be in store for it in the future. And so there's a lot of, I think, exchange to be had here between the science that's happening really close to home in our own backyard in our local solar system and also beyond at these really distant places, light years and light years away. And so that's sort of the thought that I'd like to leave you with, that there's, whether we're studying things close to home or far away, there are relationships to be had there and amazing things that tie us all together here in the universe. So thank you so much for joining us here again for another episode of Down to Earth. My name is Eric Edelman, and I'll be back with you again next week for another episode. Same time, same place, always on Slooh.com.